So, good morning student. Today we are going to discuss about the 8051 microcontroller memory organization. In that we will discuss the ROM, RAM, the registers available in the RAM, special function registers in detail. Okay, so let's start. So first of all, the features of the microcontroller we already discussed, like it is a 8-bit microcontroller. It has internal RAM which is a 128 bytes, internal ROM which is a 4 kilobytes. Then it has internal timers, two timers, that is timer 0, timer 1. Both the timers has 16 bits. Then it has 5 interrupts, out of which 3 internal interrupts, that is the software interrupts, and 2 are the hardware interrupts, or we can say it's the external interrupts. Also there is a serial communication port, okay, so which is used for the communication purpose. Then there are 4 allotted ports which can be communicated with the external devices or external world, okay. Also it has a CPU to perform the programs. They support with these registers, like a register, accumulator register, and that is a register A and register B, okay, which is perform the operations or programs through these 2 registers. So let's start the memory organization of the 8051 microcontroller. Here first we will discuss about the ROM. So ROM, internal ROM for the 8051 microcontroller, it's a 4 kilobytes. It depends on the different families of the microcontroller, 8051, 8052, yeah, 8032. So it's for the 8051, the manufacturer has provided the internal ROM, okay, internal ROM memory, which is a 4 kilobytes. That's also called as a program memory or code memory, and this is a non-volatile memory. Sorry, we cannot erase the program. After the powers gets cut off, the program will remain as it is. Okay. So in this ROM or program memory, we store the codes or programs, whatever the application is needed, okay, using some C language or using a assembly language like instructions. 8051 microcontroller have 4 different memories, like internal ROM, that is a 4 kilobytes, internal RAM which is a 128 bytes. Then ROM and RAM can be extended externally, max to max 64 kilobytes, even RAM as well as ROM. The ROM, it's a permanent memory, means we store the we load the programs or codes in that, and RAM is a volatile memory. In that the data is stored after the power gets cut off, the data will get lost in this RAM memory. So RAM is available as a 128 bytes, and max to max we can extend up to 64, okay. Then architecture of the 8051 microcontroller. We know the 8051 microcontroller used the computer as a Hava architecture. Hava architecture means they used separate spaces for the memories, like RAM and ROM. Even they access the memories through the separate buses, okay. RAM use the 8-bit data bus, and the RAM and the ROM, they use the address bus, like 16 bits. Then applications of the 8051 microcontroller. Microcontroller is one kind of the embedded system, which is embedded in the system with different peripherals. Embedded system can be one part of the big system, like a air conditioner we can consider as a air conditioner. So in remote control is a one kind of the application of the embedded system, in which microcontroller is used for the specific applications to control the temperature, to maintain the temperature, to set the temperature. ROM is used to store the data to store the code, program memory, and RAM is used to store the data for temporary purpose like variables or the any data which is used to be temporarily. So let's start here. The ROM organization, in that internal ROM has a 4 kilobytes is given in this diagram. While using the internal ROM, okay, which is a 4 kilobytes, at that time we select the pins, that is the EA bar, external access pin on the microcontroller, that should be connected to the VCC, that is equal to 2 is equal to 1. Means we are accessing the internal program memory, whatever the program we loaded inside this controller, that can be accessed by selecting this EA bar pin as a 1. Means we have to connect this EA bar pin is equal to connected to the VCC. If we are the address range of this internal ROM for the 4 kilobytes is start from the 000 hex to the 0FFF hex, that is a 4 kilobytes, but we can extend up to max 64 kilobytes. Okay, it can be a external program memory from 000 hex to FFF hex, yeah so we can consider 4 kilobytes internal ROM plus extended memory up to FFFF, that is a 64 kilobytes. To extend the memory, we can make this pin, external access pin, as a 1, but here we have to consider internal ROM address is up from 000 hex to 0FFF hex. Here onwards we have to consider the remaining part of the memory as external memory, which will start from the 1000 hex to FFF hex, but we can extend up to max 64 KB. If we are using a internal memory is a 4 KB, so we need 60 KB external ROM, okay, but 60 KB chips, memory chips, it's not available. So memory chips are available in the range of 4 KB, 8 KB, 16 KB, 32 KB, या तो 64 KB. So either we can use internal ROM or hold the external ROM to load the programs to access the programs. So for that purpose, when we access the external ROM, at that time EA bar should be connected to the ground. Okay, EA bar pin, external access pin, it should be connected to the ground. At that time we are considering external program memory, okay, program memory which is used to store load the programs, load the codes. So this is the memory organization of the program memory, ROM, okay, ROM. Then next is RAM organization. Let's see, let's check this RAM structure which is available in this 8051. So RAM available inside the 8051 microcontroller, it's a 128 bytes. So 128 bytes, how it's divided in this memory structure, let's see. 8051 has a 128 bytes memory. In that, first 32 bytes are divided as register banks, okay, register banks of the 32 bytes. Next 16 bytes is divided as a bit addressable memory, and remaining 80 bytes are acts as a scratch pad memory. Means user can use this memory space for the programming purpose. So let's start for this register banks. So it has a 4 register banks like bank 0, bank 1, bank 2 and bank 3, out of which 128 bytes the address is start from the 00H up to 7FH. Internally it has 256 bytes of the RAM, but user can be used this bytes, that is the 128 bytes from 00H to 7FH, out of which first 32 bytes are the bank register banks, second is the 16 bytes are the bit addressable memory, and remaining 80 bytes are the scratch pad memory. Means user can utilize that space for the programming purpose. So first we can select this banks, register banks. Okay, each has 8 registers like R0 to R7. Each bank, there are 4 banks. Bank 0 has registers, that is 8 registers. Same bank 1 has 8 register, bank 2 and bank 3 has also 8 register, and each bank has 8 bytes. So total 8 bytes multiplied by 4 banks is nothing but the 32 bytes of RAM, which is used for the register purpose. So register is used to access the data, variables, to handle the data during the programs. So here we can select this registers, or we can select this bank. First we can select this bank 0, either bank 1, bank 2 or bank 3, by selecting the bits which is available in the program status word register, that is the SFR, which is going to be discussed in later. So PSW, there are two bits, in which 2 bits, that is the PSW.4 and PSW.3. This 2 bits selects the which register bank can be utilized during the program. By default, bank 0 is selected in the programs. When we does not define any bank at that time, it takes default bank, which is a bank 0. So out of which R0 or R0 to R7 is selected from the bank 0. Okay. If we want to select the bank 1 or bank 2 or bank 3, we have to load this registers, that is the PSW registers. In that PSW4 and PSW3 bits we have to load with this values, like for the 00 means bank 0, 01 means bank 1, 10 means bank 2 and 11 means bank 3. So like this we can select the banks by programming through these PSW registers. Again, so RAM address, here some examples is given here. So RAM address of 00H to 1FH holds the 4 registered banks. Okay, this 00H to 1FH, the address for the register banks is start from the 00 hex to 1F hex, total 32 bytes. So for the bank 0 is 00 hex to 07 hex. Each register has 1 byte. So R0 is for the 1 byte, R2 is 1 byte, like this up to R7. So total are the 8 bytes. Similarly for the bank 1, similarly for the bank 2 and bank 3. So just check this example, move A comma R0. It indicates copy the contents of the R0. Okay. What example is given? Move, instruction is move A comma R0. So we have to copy the contents of the R0 of bank 0. If we are not selecting any bank, by default it selects the bank 0. That means the contents of the R0, whatever the values is stored in the R0, means it can be any value 1111, 1111 means FF. Yeah, it can be a whatever we are discussing earlier, that is the binary values can be available in this R0 that we have to store into the accumulator. 8-bit data, all are this 8-bit data, and this bank registers are the byte addressable, it's not a bit addressable, means we cannot be program individual bits, we have to program whole the byte, like R0, R1, whatever the bits are available, that is the 8 bits, whole bits we have to access as a byte. So here move A comma R0 indicates that the contents of the R0 we are loading into the accumulator as it is. So R0 can be content from 0000 like up to 1111, 1111. Similarly, move A comma 08 hex. The meaning of this, the copy R0, same meaning is the same, copy R0 of register bank 1 into the accumulator. Now here we are accessing this bank 1 register 0. The address of the bank 1 register 0 is 08H, and address of the R0 of bank 0 is address is 00x. So the meaning of this move a comma 08 hex is that the content of the R0, whatever the data is available in this R0, okay, bank 1 register 0 is loading into the accumulator. So we can program directly using the address, okay, using the address of the each register. So R0 has the address. What is the address? 00x. For R1 01 hex, for R2 03 up to R7 07 hex for the bank 0. For bank 1 the address of R0 register is 08 hex, like this. It defined by this addresses which is available. So microcontroller is a bit addressable area also, which is start from the 20 hex to 2F hex. Okay, bit addressable. Bit addressable means we can program each and every bit. Okay, here see 16 byte of RAM, which is a bit addressable. It start from 20 hex up to 2F hex. This is a space which is provided for the bit addressing programming. Means we can program individual bits like set bit, clear bit, rotate bit, like we can operate each and every bit, but in this bank we cannot handle the individual bit. We have to handle whole the byte, whether it's R0, whether it's R7, we have to whole byte, that is the address 008 hex, we have to handle whole the address, whole the byte. But here in bit addressable area we can program individual bits, okay, individual bits. The addresses start from, again individual bit has a separate address which is start from 0 to 7F, okay, in this area bit addressable area which is start from address is 20 hex to 2F hex, total are 16 bytes. In that the address is given as 00 to 7F individual bit for the individual bits. If you want to program this 07 bit, you can do this. Means if you want to set this bit 07, so we can write a program like set bit 07x. So it means we can make this bit as a 1. Make only this bit as a 1, other bits will remain as a 0. So it's possible to make as a bit addressable. After that 30 hex to 7F hex, okay, means 002 127, 002 127 bytes, 127s, out of which 80 bytes of RAM is a general purpose RAM. We can use for the as a scratch pad memory. We can store the program temporarily at these areas. For that purpose we use the push instructions, pop instructions, temporary data can be stored over here. Okay, so this is a memory organization of the internal RAM from 00 to 127, that is a 128 bytes, which is a user defined RAM area. Okay, user can use that. And after this 80H to FFH, remaining 128 bytes, that is a special function registers. That part also we have to discuss. See here the examples for this bit addressable areas is also given. Check this, set B 7F, set B instruction is set B, which is used to operate, which is used to handle the single bit in this bit addressable area. Okay, that is a set B 7F, set B 7F. Okay, we have to set, means we have to make this bit as a 1. If you want to make this bit as a 0, so we can write clear B 7F. So we can make this bit as a 0. So like this, set MSB of 2F RAM location, RAM location. This is the RAM location, which is a 2F hex. This is the address of this whole byte, but inside there 7F is a single bit. We can operate that bit. So like this, clear 08H. Clear 08 means we are clearing this bit of the address of 21 hex, RAM location of 21 hex. We are clearing the 08 bit of the 21th locations, and then move 20H. Okay, move 20H. 20H is the address of this RAM location, comma hash FFH. The meaning of that, this address, the RAM location which is a 20H, the bits of total 8 bits, we are going to be a 1 ones. All the sets, we are set all the values for the bits from 00 to 7H, we are making as a 1. So this is a RAM organization. Okay, just remember, first 32 bits for the bank, we can select the register banks from this 4 banks. Then 16 bits are the bit addressable area. We can program individual bits, and remaining 80 bytes are the scratchpad memory. So this is a total 00 hex to 128 bytes, total bytes 128 bytes, which is available for the internal RAM in the 8051 as a user defined. User defined, we can means user can use this space, memory space, RAM space for the programming purpose. And remaining from 80H to FFH are the special function registers. The locations are the special function registers. So memory space, which is start from RAM, the RAM is start from 00 to 128 internal RAM, out of which we can extend, we have available RAM up to 255H. Okay, 255 means we can utilize 0 to 7F, 0 to 7F, that is a user defined, and remaining, that is the 80H to FFH, 80H to FFH, that is the another 128 bytes, that is defined by the SFRs, special function registers. So total SFRs are available, that is the 21 SFRs to control the different programming methods like arithmetic, like port, like controls. So SFRs are divided into the different categories. Let's check. So SFRs, a group are categorized into the 5 to say different categories, 6 different categories, like math or CPU registers. So they used accumulator like a register A and register B. Okay, here most of 8051 microcontroller, it's 8-bit microcontroller, so it operates only 8-bit data, but some registers in this architecture of the 8051 microcontroller has a 16-bit register, 16 bits. So we have to divide that 16-bit into the 2 8-bit registers. Then CPU of the 8051 microcontroller operate that, perform that operations. So here the SFRs are divided into these 6 different categories, like a math or CPU registers, in which register A and register B. Okay, these are the SFRs. Total, these are the 21 SFRs, but divided into the different groups. So first is maths or CPU register, that is the A and B. Both are the 8-bit registers. In detail we will discuss. Then status registers. Status register, that is a PSW, program status word, or we can say it's a flag register, which is also 8-bit register. This register is used to store the data of the accumulator for the performing the operations of arithmetic and different operations. Then pointer registers, that is the DPTR and the stack pointers, is used to while handling the external program memory. So data pointer and the stack pointer. Then IO ports. This also has the port has also registers which are the 8-bit registers. So there is a addresses also provided in the SFRs. This is one kind of the register, that is P0, P1, P2 and P3. These are the ports, but it has the internal registers, 8-bit registers. Then peripheral control registers like a PCON, SCON, TCON, TMOD, IE and IP. These are the control registers used for the PCON, like a serial communication. Then TCON, TMOD, like used for the timer operations. IE and IP is used for the interrupt operations, interrupt related applications or operations. Then peripherals data registers like timers. The timers has there are two timers, timer 1 and timer 0 and timer 1. So it has the internal registers. Both the timers has a 16-bit, but they are divided into the 8 bits, like a timer 0 lower bits, timer 0 upper bits, TL0, TH0. Similarly, timer 1, TH1, TL1 and the SBUF registers, okay, which is used for the serial communication purpose.